Then what?
Then in parentheses is 1 minus r. I was
So first of all, this is a growth problem, so it would have been 1 plus r, but because they give us this e, we use that e instead of the 1 plus r.
okay.
E here. Okay, we don't know r, and then what was t?
12.
Yeah. So we're just filling in everything we know into the given equation. Okay, thank you, Henry. What questions does anybody have? Okay, if nobody has any questions, this is for number 1 on the warm-up. All right, we wrote the equation that can be used to solve the problem. Then it says, let's see, solve the exponential equation using logarithms. Okay, so it says this is the model. It doesn't really give us a problem. The thing that we're solving for, though, the only variable that's there is to find the rate. Okay, so we're going to try to find the rate. And we're going to find the rate by solving this equation using logarithms. So Monica's not here. Katie, can you help me out?
Yeah.
Okay, so what do I need to do first?
I don't know.
Write my equation. And the first thing I want to do is I want to get everything we got in the exponential function on both sides. So how do I get this 150?
Subtract 150 from it.
So that would be if you're adding, but 150 is being multiplied by this exponential. So we're gonna, what's the opposite of multiplying?
Dividing.
Yeah, so we're gonna divide by both sides by 150. So if I calculate divided by 150, I should get, let's see, 13.3. Katie, can you help me rewrite this as a logarithm?
Yeah, hold on. So would the base be 13 or would the base be e?
The base will be e, so I'll have log base e.
And then the exponent, which is 12.
So the exponent is r times 12.
Okay.
But what goes inside of the logarithm?
The base.
So the base is here. And then this is the stuff inside. And there's something else that goes inside.
I don't remember.
So what have you not said? You tried
The answer?
yeah, the 13.3.
Okay.
And then we're going to set that equals to the exponent.
Yeah. Okay.
Okay, so if I highlight this, thank you, Katie. You can go. Did I highlight this just like I did the other day? So I had an exponential where this was my answer. This was my base. And this was my exponent. I rewrote it so that I had my exponent here, my answer here, and my base here. Okay, so that's how I rewrote it, just like we did the other day. Now, log base e, we can abbreviate to the natural log. Okay. Now, if we're solving for r, we would want to divide by 12 on both sides. So r is equal to the natural log of 13.3 repeating over 12. And we can solve this by putting it into Desmos. So I'm going to pull up Desmos. You could also probably use your phone calculator. All right, we're going to type in the natural log, so the miscellaneous, and find the natural log.
It's 13.3. And it's still repeating, so I'm going to put a bunch of threes in. And then I'm going to divide that by 12. When I do, I get 0.2159
if I round. So my rate should be 0.2159 or a 21.59% increase in bacteria. Okay, so we set up our equation using the given formula and the information that we had, and then we found the rate by rewriting our exponential function as a logarithm. What questions do you all have about that process? And I think that there probably should be a lot of questions about the process. So if you have a question, please ask. Okay, any questions at all? Okay, you guys are going to be expected to solve. So I need you to ask questions if you don't understand. Okay, you guys are good. Then we're going to go ahead and start notes for our day. So let me make this bigger. Okay, and thank you to my volunteers from the warm-up, Henry and Katie. All right, so today we're talking about the inverses with exponential and logarithmic functions. Okay, so we kind of talked the other day about how exponential and logarithmic functions are inverses. Okay, and so we want to explore this a little bit further. So first it tells us to graph each of these functions using exact coordinate pairs. So the line y equals x is the easiest one to start with. So I'm going to graph that one first. So the line y equals x is just a line that passes through the origin, and then it's going to pass through each of these points where the y value and the x value are equal. So I'm going to just grab a ruler. If you're doing this on notebook paper, just put a grid real quick. And I'm going to draw a line through all of those points, making sure that I pass through everything I need to. All right, so this is our line y equals x. And I'm going to highlight that in the same color that I highlighted it on the side, so you guys can see exactly which graph it is. Okay, so that's that graph. Then it asks us to plot y equals 2x and y equals the natural, or the log base 2 of x. So if you have no clue how to find that, you can either make a table, or because you guys are always allowed to use Desmos, you can just type it into Desmos. So I'm going to type in 2 to the x, and I get this function right here. And I get different points along the way. So I'm going to plot those points. So I know I have a point at 0, 1. Let's see, what else do I have? I have a point at, it looks like I have a point at, let's see, where are you? 2, 1. So 2. No, that can't be right. So at 1, I should have a point at 2. It was 1, 2. All right, at 2, I should have a point at 4. At 3, I should have a point at 8. Okay, and then let's do some to the left over here. If I have -1, I should have 1/2. All right, and if I have -2, I should have 1/4. And so we see we have this exponential function getting super close to the x-axis and then skyrocketing up towards the top. Okay, and you can just look along. So if you take this point and you drag it, or it should work. If you drag along the function on Desmos, you should be able to see it. If you can't, you can type in like x equals any number really, 5. And then you can go up here and find the intersection, and that's the value for 5. Okay. All right, so that was that first one. I'm going to highlight it so you guys know which function that one was. So y equals 2x squared is this function right here. And then y equals log base 2 of x. So to type that one into Desmos, you go to functions. We want the log with the little a at the bottom down here because that lets us pick our base. We want our base to be 2, and we want x inside the function. I want to close my parentheses. So now, if I go back down and look, here's my function. Okay, so I have a point at 1, 0. And then I have a point at 2, 1. I have a point at, let's see, I want to see all my values. So I'm going to make my step 1 for my x and my y. Oh, why didn't it do it? Interesting. Let me let somebody in. Oh my goodness. Just dropped everything. Okay, so let's see what else. I could have the point 4, 2. And the 0.83. And then it's going to go off like this. Excuse me. So it's going to go off like that. And then this side is going to get really, really, really close to that y-axis. Okay. You can use Desmos to plot those. And look and see what happens. Okay, now we noticed this when we did notes the other day. We noticed that the pink is a reflection across the y equals x line, the yellow line right there. Okay, and so we can write that here where we say, what do we notice about these graphs? We can say they are reflections of each other over the line y equals x. Okay, so we're reflecting across that yellow line. And that asks, what does this mean about the relationship? It means that these functions are inverses of each other. Okay, if you remember nothing else from our lesson today, remember that logs and exponential functions are inverses of each other. So logarithms and exponential functions are inverses. Okay, so in general, if you have a function f of x equals b to the x, its inverse, f inverse of x, should be equal to log base b of x. Okay, similarly, if you had an original function, this is literally the same thing but backwards. If you had your original function was log base b of x, your inverse function would be b to the x. Okay, those are inverses of each other. What questions do you guys have so far? Okay, so we're gonna do a lot of practice with converting back and forth today.
Miss.
Yes.
So in general, where you wrote, so that's the original function.
So yeah, I'm saying if your original function is an exponential, your inverse will be the logarithm with the same base.
Okay.
If your original was the logarithm, then your inverse will be the exponential with the same base.